Hello students, in the chemical properties of metals and non-metals, today we will discuss about displacement reactions. A reaction that takes place when an element replaces another element in a compound is known as displacement reaction. We will study about the displacement reactions with the help of an activity. So students, in this activity, you have to take 5 beakers of 100 ml and label them A, B, C, D and E. Now in each of the beaker add about 50 ml of water. Then add the mentioned substances in the beakers one by one. In beaker A, add copper sulfate and zinc granules. In the beaker B, add copper sulfate and iron nail. In beaker C, add zinc sulfate plus copper turnings. In the beaker D, add iron sulfate plus copper turnings. And in the beaker E, add zinc sulfate plus iron nail. Keep the beakers undisturbed for some time and then record your observations. Students, you will observe that the blue color of the copper sulfate in the beaker A disappears and a powdery red mass of copper is deposited at the bottom of the beaker. The color disappeared because of the formation of zinc sulfate. In the beaker B, the color of the solution changes into green and there is reddish brown deposition on the iron nails. The color becomes green because of the formation of ferrous sulfate. And in the beakers C, D and E, as you can observe here, there is no change. Now students, we will study the related chemical equations. In the beaker A, as you can see, zinc replaces copper from the copper sulfate solution to form zinc sulfate, and the deposition of red mass of copper takes place at the bottom of the beaker. In the beaker B, iron replaces copper from the copper sulfate to form ferrous sulfate, which is green in color, with the deposition of copper on the iron nails. So students, you have seen that in these reactions, one metal has displaced another metal from its compound in aqueous solution. So students, these are the examples of displacement reactions. But students, in the beakers C, D and E, there is no change. That means that copper is not able to replace zinc from zinc sulfate in the beaker C, or the copper is not able to replace iron from the iron sulfate in beaker D, and iron is not able to replace zinc from the zinc sulfate in the beaker E. Why this happened, students? Because there is a definite rule, and the rule is that zinc is more reactive than copper and iron. A more reactive metal can replace a less reactive metal, but a less reactive metal cannot replace a more reactive metal. This is the reason, students, that there are no displacement reactions in the beakers D and E also. Here, students, you can see the reactivity series also. In this series, the arrangement of metals is made in the order of decreasing reactivity. Here, students, you can see that copper lies below zinc and iron in the reactivity series, and iron lies below the zinc in the reactivity series. And as per rule, a less reactive metal cannot replace a more reactive metal. Hence, students, there is no change in the beaker C, D and E.